Okay. All right. So just some, I don't know, housekeeping stuff. Okay. So I put up a link on our course CCLE under week 4.
Okay.
There is group project.
There it is.
Checkpoint 1, which you don't actually do anything here. This is just an entry in the grade book for me to check off that you did it. But basically, you're going to click this link for the Google Sheets list of groups. And what you will do is you will, this is just an example row, okay? You will list off your, put your group name, and then put in the GitHub repo URL, okay? Because all of your group activity and stuff, work will be done via GitHub. You're not going to submit things to me. I'll click on your GitHub link, and then you'll put you know, the student's name, and then each student needs to have a GitHub account, all right? And that will be here. And then on the GitHub repository, what I will be looking for is I will be clicking contributors, and I want to make sure that each person in the group is listed as a contributor for the repository. Okay, so that's what you need to do. So by Friday, you just need to put in your group information. Okay, and then I just ask that you fill this out kind of sequentially. Don't be like, oh, I want to be group double B, and you know, jump down there. Okay, because with 68 students, the maximum number of groups will be 34 because we have to have a minimum of group size 2. But if a bunch of groups have 3, then we'll only have, you know, 22 groups, 21, 22 groups, and then I don't want to have to, like, I don't know, I don't want empty things. So anyway, just fill it out sequentially, please. Okay, that's all. And if you need help finding a group, you can go on Piazza and kind of see if anybody wants to join your group, and that will be that. So that's due at 6. So to add somebody as a contributor to your repository is you know, once you create your repository, you go to Settings, and then you'll go to Collaborators. And let me go there, and then on the collaborators you will add your collaborators here, okay? And so on this one I have my kind of fake account just to kind of demonstrate how this goes. And so so each person needs to be kind of listed there, and then I'll just be clicking this contributors thing to kind of see. You know what? I'm not 100% sure. You might need to make a commit in order to show up in the contributors tab. I'm not 100% sure on that, but that makes sense. Okay, and the nice thing about GitHub is, you know, you can see the commit history, and so you can, in a group, you can see who's contributing, right? So it'll be clear if just one person is carrying the weight of the entire team, because it'll look like this, where all the commits are made by one user, and you know, there's you know, something like that. So so anyway. But you know, don't make, well, anyway, okay. But that's the idea. Is you know, I hope each team member will make commits. And if you just need to make like a base commit, all you have to do is just, you know, touch a file and commit that, and that will, you know, every group can make a commit that way. Okay. Are there any questions on that? You guys have been thinking about your groups. So so this Friday you just need to get your groups listed, okay? And then next week we'll have another checkpoint And by next week, I want you guys to have a data set identified, okay? And then we'll just have kind of little weekly checkpoints and just to make sure we're not like piling up the report all the way to the very end. Yes?
Is the checkpoint grade part of the final project grade?
Yeah, you know, I'll have to figure it out. It'll count for something. Because right now the way I have it split up is report, video, and slides or something. But I'll probably have to put in like a checkpoint contribution, and I'll figure out the exact point scheme there. Yeah, but yeah, the checkpoints will count for something. Yeah. Okay. And then and I've never done a group project on CCLE. Have you guys done group things on CCLE? So CCLE Moodle, it supports like student groups, and so I think I have to like manually create these, I think, and I think you can then, I don't know, submit stuff as a group, and I think what that allows me to assign a grade to the group, and it causes the grade to show up in all the group members things, I think, but I'm not 100% sure. I've never done this before, so we'll try to figure it out. And you know, as anytime you try out a new technology or new feature, it may or may not go as planned. So just please be patient with that. Okay, patient and forgiving, please. Okay, is that all right? Any questions about this? No, we're good. Have we? Do we have groups in mind? Sort of. Okay, good. All right. Okay. Well, are there any questions before we move on? Yes.
I have a general question.
Yeah.
How should we be studying in terms of like the midterm?
Yeah, this is a good question because I haven't written the midterm, and I'm not 100% sure how I should write it. I'm still thinking. Okay. I'm debating in my head whether I should. I might choose to do something. The default is to do something like the Stats 102A midterm, but less tricky and more straightforward. But you know, I mean, we're covering a lot of, we're spanning a lot of stuff, right? So I'm not, so you know, if I do a midterm, it'll be mostly like a breadth and vocabulary rather than like tricky typos that see if you catch them type of thing. But yeah, it's as I'm teaching this class, I'm realizing it's hard to fit everything I want to fit in 10 weeks, you know. So, and you know, I can see kind of who's been completing the assignments on Data Camp, and not many are are following the idealized track of about, you know, one. So I was going to do, you know, 1 to 2 courses a week, and so maybe 2 is on the heavy side, and so yeah, they can be long. So so I'll try to limit it down to 1, but I feel like, you know, we won't get to cover as much if we do it that way. So you know. The good news is I think Data Camp told me you guys will have access to the premium content through like at least through the summer. I don't know. I think it says through like October 1st or something. I don't you know, I don't know 100% about that, but that's I mean, that's nice, right? I mean, because I think it's like $30 a month otherwise.
Do they have educational pricing for?
No, it's
just in general.
It's like if you use it for a class, it's free, right. And then after that, you have to pay $30 a month, basically. Yeah. So. And then every now and then they'll have a promotion where it's like, buy the year for $150 or a year for $200 or something like that. So that's like a sizable discount. Okay, I was gonna move on and go into Matplotlib, but you know, they're like, we spent some time on Pandas, and Pandas, like, you can get like really deep into it. If you're coming from R, there's like Pandas does things, some similar things, like the group by is nice, and it does things that R doesn't do, like the pivot tables and stuff. But then there's other things that R does that isn't handled as nicely, like dates with R, there was that package Lubridate, which made everything like super nice and super easy, and Pandas, or Python's kind of internal datetime functions are a little bit more strict and rigid, and so, you know, pros and cons to everything. But all right, we'll start doing intro Matplotlib, okay? And this is kind of if you're gonna make plots, it's gonna be done via Matplotlib pretty much, okay? The syntax for Matplotlib is different from R, but it, you know, certain things there's certain similarities, and okay. Anyway, let's start. We'll start by importing NumPy as NP. Here I'm doing basically starting off with a blank Jupyter notebook here, and we'll work through it. Okay, and then the convention is you do Matplotlib, and the kind of the thing within Matplotlib is pyplot. Okay, so you're going to do matplotlib.pyplot as PLT, and this gives us the ability to kind of create plots, and we'll get that running. Okay, and then so now we can start doing you know, graphing functions and things of that nature. Okay, so maybe you want to create you know, a sequence of values. All right, so if you want to plot like the function, all right, so let's plot I don't know, a function like sine of x. Okay, so what we can do is we can do we're going to use NumPy, so NumPy, and then we'll do a linear spacing from 0 to we'll do np.py times 2, and then we'll have a length of, we'll do 500. Okay, and then oops, okay, and then y will do the sine function of x. Okay, and then we will call pyplot plt plot, and we'll just do x and y. Okay, and then the thing about the plot commands is each of these things kind of give instructions, and they don't appear until you ask Python to show the plot. Okay, so I'll do plot plt.plot, so this kind of creates the I guess of course it shows as soon as I enter it, but normally you do plt.show. Okay, and there we go. So we have the function of sine of x. Okay, if you wanted to add titles, you would do something like plt title sine of x. Okay, and it would add add the thing here, and I'm not used to this behavior here. And then we click show plt dot. All right, what am I doing? Let me put everything into one box, and then we'll call it. Okay, so we'll say, you know, plt.plot. We got x and y. So basically, x is just a vector, and y is also a vector. And then, you know, similar to R, you can create when you create a plot, it just kind of connects them all. Okay. Likewise, if we created like a small vector, like no, it's the wrong format. Okay, so let's just do from 0 to 5 by 1. Okay, so and then so x is this, print x, and then y. All right, and then random.randint p.random. What am I doing with randint? That's wrong. Okay. Print y. All right, and then we'll do a plot. So plot dot plt dot plot x and y. Okay, and then we'll just do plt dot show. All right, and so it just connects them. It's kind of like in R, it would be like type equals L, and it just kind of joins the dots with lines. Okay, but if you wanted a scatter plot, you can do plt.scatter x and y, and then we'll do plt show. Okay, and you'll get a scatter plot. Okay, we have, so that's these are kind of your commands. So plot will default to a line plot. Scatter will create a scatter plot. Other things, we have things like histograms. So I can just do z is numpy random dot random normal, and I think I call for, let's say, 1,000 values here, and then we'll do plt.hist z and plt.show. Okay, and so there's that. You can specify more bins and get something like that. Okay. Even more random numbers. Okay, so these are kind of your basic line plot, and then scatter plot and histogram here. Okay, you can do multiple if you have kind of two different functions. So here I have x. We'll go back and we'll copy this linear space stuff. Okay. So multiple functions, or sequences on the same graph. So here I've got x will go from 0 to 2 pi, and y will be sine of x, and then we'll have z equal tangent of x, okay? And we can call plt dot plot x and y, and we'll have it go in blue, and then I can do plot x and z, and we'll have this one appear in red, and then I'll do plt show. Okay, so you can just kind of, so this is calling these will give instructions to create, load up an x and y line plot and an x and z line plot, and then show will show the resulting thing. And of course, now that well, because I threw tangent in there, you can hardly see the squiggle that sine of x produces. Let me what's another, we'll do w is cosine of x, okay? All right, so if I do the same thing here, except we have w in green. Okay, so here you have kind of as expected, the plots of sine of x and cosine of x, but over here, because the scale of tangent, which goes into infinity, positive and negative infinity here, creates a problem on the scale of our graph. So what you have to do is you have to end up, you can request that the graphs appear separately. Okay, there is something called a subplot. Okay, so so the scale of the two graphs, or the two functions, make this graph undesirable. Okay. All right. So here we'll do subplots. Subplots to show different functions. And effectively, we're just making different plots, but kind of creating them. Okay. So what you do is you call plt subplot, okay, and it's how many rows by columns. It'll be a number of rows, comma, number of columns, and which plot you want to draw. Okay, so here I'll do we'll do 2 rows, 2 columns, and we'll just do the first plot here, and then we'll plot x and y. Okay, this is the sine of x, and the default here, and so and here we'll do the title will be sine x. Okay, and then we'll call subplot to let it know that we are going to work on a different plot. So it'll be 2, 2, and 2. So this will be number 2. Subplot 2 will be upper right. So subplot 1 will be upper left. It goes upper left, upper right. So it goes across the rows on top, and then it goes across the it goes across the row, and then it goes to the next row, and something like that. Okay, so we'll call plt.plot. We'll do x and w, and the title here will be cosine of x, and plt subplot 2 to 3. This is subplot 3 for will be lower left, plt plot x and z. plt.title will be tangent of x. Okay, and then we'll finally call plt show. All right, so we got sine of x, cosine of x, and tangent of x there. And it puts the kind of, it's just, you know, we're making separate commands here, and separate plots, but it puts them together. Okay.
There's no function like rm frow like an R that says you just put 2 by 2 and then you run all the columns to call it that. You have to do it manually.
Yeah. So this is kind of like par-mf row, except, well, here, let me see. I think. Yeah, no, this, you need to call the subplot command to kind of let it know that you're moving to another plot, okay? Okay. Let me see. What else? Oh, okay. Well, I don't know. You can change kind of your axis limits and things like that, and X labels. So I'll just say, okay, change labels and axis limits. Okay, so you've got, so you kind of establish what you want to plot first. So you'll say like plt plot. So we'll do X and Y. So this is plt title sine of X, okay? The X label, plt X label, is just what's going to go on the X-axis. So this will be, we'll call it X, and then plt.Y label, I don't know what we want to call it, sine X, f of X, whatever you want to call it, right? All right, let me just do plt.show. All right, so all that does is just label the thing, not a big deal. Okay, and then, so here I just made a copy of this. You can modify the axis. You can do xlim, and this, and you give it a list or a tuple. So a list is a mutable object, and a tuple uses parentheses, and it's immutable. But I don't think anybody really cares that much. Okay. No, I mean, okay, no, it makes a big difference. But as far as like throwing them into xlim, a tuple or a list is fine. Okay, so here we can do go from 0 to pi over 2. So I'll do np.pi over 2, and then we'll do plt.show. Okay, and there we go. So one thing is that when you do the when you draw the x limits, it the y scale is based on kind of the range of y. Okay, so when you do plt.plot, it kind of determines the range of x and the range of y. And so even though from 0 to pi over 2, it only covers, it's only positive values, it only, it doesn't adjust it, okay? If you want to adjust that, you can set the y limits yourself. And let me see, matplotlib Autoscale. PLT Autoscale true. Let's try that. Okay. think enable equals true. I think no, that we want axis. We just want the y-axis. All right, let's try this. You know what? Maybe this is not what I want. Okay. I thought this was. Nope. Okay. All right. I'll have to figure it out. I don't know if there's a way to get this to autoscale here, but okay. Sorry. Okay, so that's kind of just plotting some legends there, and you know other things such as if so in R there's something called aspect ratio, and here in Python we call it axis equal, and this kind of makes sure that the scale is, you know, you get these kind of square grids. So okay, let's see what else we can do. All right, sometimes we want a two-dimensional function, a function over two variables, and there is a NumPy thing that allows us to do this, and this is called a mesh grid. Okay, so let me bring this up. Okay, so two-dimensional functions, and so one thing to note is that this thing looks like it's a smooth function, but because it's on the computer, it's not really a smooth function. We have I don't remember what my x is, but x is just a it's this array with 500 values in it that are you know, nicely spaced out between 0 and 2 pi. And the way the function works is that it says, okay, if I plug in 0 for x, what do I get out of y? I get 0, and then at the next thing, you know, 2 pi over 500, you know, 0.0 something, if I plug that in, what am I going to get from sine of x? And it gives you a little value, and so puts basically a dot there, and it just connects all the dots together, okay? And so if I did, I don't even know what this will look like, plt.scatter. This will probably still look smooth. Okay, we got too many dots. Yes, Cameron.
We're gonna go over like more like interactive class too, like something similar to Liquid.
Like bokeh or something. I was not planning on that. There is a data camp course on that. I was mostly gonna focus on static things. Again, we could be like super ambitious, but so there is a course on data camp that goes for interactive stuff, which, you know, if you got the time and interests you, definitely you should check it out.
Are you able to link it as like optional?
Yeah, I can link it as optional. Yeah, sure, no problem. Okay. Okay, you can't really see, but it's, you know, if we were to zoom in, dot axis xlim, we'll go from 0 to 0.1. Okay, so it's just plotting just connecting a smooth line between each of these dots here. Okay, and that's just how computers render functions. Okay, it doesn't understand. It's impossible to have continuous values because continuous means you have infinitely many values between any two numbers, and we're on a floating point system, and so we have a whole bunch of numbers, but there's only a finite number. Okay, and so so even though it looks continuous, it's really just a series of dots that are just connected smoothly. Okay, and the same thing applies to two-dimensional functions, is that we're going to just create a series of dots, but this time it forms a grid. Okay, and each grid point has a different value, and we can smooth it over with something like contour lines, or the grid nature of it is especially visible when you do what's it called, like a raster type thing. Okay, so here I'm going to just create we can do np linspace. Let's go 0 to 2, and I want we'll go three values. Okay. You know what? Let's just do 0, 1, and 2, and then y. We'll go -1, 0, and 1. Okay. Right. Why am I? No. np.array. My brain is totally drawing a blank here. How do I just make a? What is it? Hmm? Oh. Oh, okay. That's. I'm just being stupid. Okay. Okay. So if I print x and I print y, this is what we have, and then there's a function called mesh grid. And when you do mesh grid, you're gonna get two. You're gonna get these arrays here. Okay. So actually, let me just make this one. So I've got 3 and 4, and I'm gonna make this capital X and capital Y. And let me just print out what capital X is and print out what capital Y is. Okay, so X is 0, 1, 2, and then when I throw it into mesh grid says, oh, X is 3 and Y is 4. Okay, so when I create a grid of 3 by 4, I'm going to get a grid of 12 points. Okay, 4 columns, 4 rows tall. So it sees X has length 3, Y has length 4. So the result is a 4 by 3 grid. Okay. And so here we've got basically 0, 1, 2, X is repeated 4 times. Okay. And then Y is repeated. It's transposed to be vertical. So -1, 0, 1, 2. It's transposed to be vertical, and it's repeated 3 times, so that we end up getting basically this mesh grid here. Does that make sense? No. Let me let's take a look. Okay, so X is equivalent. So after applying mesh grid, this is equivalent to taking what X is, and I put it there, and I put it there, and I put it there, and I put it there. Okay, because equivalent to repeating x 4 times because y has length 4. Okay, and then y is equivalent to taking y and repeating it 3 times because x has length 3, except it does this one vertically. Okay, except it repeats it, it makes y vertical. So it's like this, this, and this, and then transposed. Turns out quite frequently. So, so yeah, what it does, it's kind of like applying an outer function. So in R, you would take a vector x and a vector y, and then you'd throw it into outer, and you'd do outer x, y, and then you'd put in the function. Okay, so in R, you could do outer x comma y, and then you'd have a function equal to something like, let's just do x plus y here, okay? Or we'll do x times y, all right? In Python, we would well, we would have to define a function, and we never actually covered this. We never defined how to define a function. But you define a function as like this. You'd say define f as a function of xy colon, and then and you would return. Here we're just going to do x times y. Okay, and that's our entire function. And then so here we would do we'll take z and just do f of big X and big Y. Okay, so we use mesh grid. I mean, I could do it here, no problem. Okay, so we take X and Y, we do mesh grid. That turns X into a 4x3 matrix and Y into a 4x3 matrix. And then we apply the function X and Y, and basically this allows us to kind of do it element wise. Okay, whereas R, it creates the it does it for us in kind of one thing. Here it breaks it apart a little bit, and let's print out Z. Okay, and so this ends up being the product of X, which is 0, 1, 2, and Y, which is minus 1, 0, 1, 2. Okay, and we can kind of see this, and so. Oops. And so you can do something kind of, you can do something big like np.linspace I don't know, -4 to 4 length of 400, we'll do 401, okay, and then Y, we'll do the same thing, and then we'll capture big X and Y as np.meshGrid xy, and Z, we'll define our function, define another function G of X and Y to be, let's do, okay, so let's do np.exp. Wait, that's the function, right? Let me just want to make sure np.exp of np.e. Yeah, okay. np.exp, and we're going to do x minus x big X squared times np.exp of minus y minus big Y squared. Okay, so what's this going to look like? Okay, so z will be f of x comma y, and then we don't want to print z, but we'll do a plt dot plot, or actually not plot. We want to do we want to create a contour plot, so we'll do a plt dot contour, and in this case we'll take x and y, our mesh grids, and did I do this wrong? Maybe. E to the negative x squared, y to the negative x squared. Okay, so we do that, and then you can create a contour plot, plt.show, and you get kind of a contour plot. If you don't want a contour plot, you can you can also do kind of show the kind of the raster nature of this. Okay, so contour makes it look like there's kind of smooth lines appearing all over the place. But I think we can just do image im show. Let me just do okay, I think it's there's too many values for us to, it looks smooth, but it's not smooth. It's a bunch of grid points, right? So we have to keep that in mind. And okay, anyway, I've totally run out of time. There's a lot that we can do with Matplotlib. So I'll make some more graphs and stuff that and kind of try to show you just I don't know, some useful graphs that we can use here. Okay, we'll end here for now, and we'll see you guys on Wednesday. On Wednesday we'll have a short quiz on Pandas stuff.